2. Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's DevOps.com webinar, Most Common Misconfigurations in Kubernetes, Benchmarking in K8s, brought to you by Fairwinds. We have a great webinar for you today, but before we get started, I need to go through some housekeeping announcements. Today's event is being recorded, so if you miss any part of the webinar, you will be able to access the recording for on-demand viewing. We will be sending out a link to access the webinar on demand, or you can visit devops.com/webinars. We want to hear from you today, so please feel free to send in your questions at any time throughout the program by using the Q&A tab. We also encourage discussion by using the chat tab, so let us know your thoughts or just say a quick hello. We also have a couple of polling questions during today's events, so we'd appreciate it if you could take a couple of seconds to submit your answers when you see those come up on your screen. And finally, stick around until the end because we are doing a drawing for 4 $25 Amazon gift cards. So stay tuned to see if you're a winner. Joining me today is Kendall Miller, President of Fairwinds, Joe Pelletier, Vice President of Product Strategy at Fairwinds, and Robert Brennan, Director of Open Source at Fairwinds. And with that, I'm going to put myself on mute, turn off my camera, and let you begin.
Thanks, Julio. Welcome, folks. This is Most Common Misconfigurations in Kubernetes, where we're going to be talking about benchmarking in Kubernetes, which I think is something that we're relatively early to. I don't think there's a lot of people doing benchmarking on Kubernetes, so I'm excited to be presenting the things that we're talking about today, show you the findings that we've found, and talk you through the relevance of those things. So hopefully that's what you're here for, because that's what you're getting today. We'll go ahead and dive in. So first of all, my name is Kendall Miller. I'm president at Fairwinds. Been involved for a long time at this company. Been doing Kubernetes for almost 6 years, exclusively at Fairwinds, and talking to people about the problems in Kubernetes over the years. We've seen it change from Kubernetes is really hard to stand up to Kubernetes is really hard to configure right to, okay, now I have Kubernetes, what do I do now? And it's been interesting watching the life cycle of that. The problems that we're talking about today are even interesting partly because they're mature problems. Kubernetes has come a long ways, and so the problems that people are running into and the issues that they have and the benchmarks that we found are relevant to today. So I'm excited to be here to talk about this with you. Joe, do you want to introduce yourself?
Yep, my name is Joe Pelletier. I'm a head of product here at Fairwinds. I've been working in the cloud and DevOps and security space for quite some time, and so really excited to share with you what we've learned from our benchmark report. And Robert?
Yep, I'm Robert Brennan, Director of Open Source Software here at Fairwinds. I've been working in open source for about 6 or 7 years. I've been working in Kubernetes for about 3, so I'm excited to talk to y'all today about some Kubernetes benchmarking stuff.
All right, and before we dive in, we just want to share a little bit about how this is created. So Fairwinds builds software for Kubernetes governance, configuration validation. Basically, everyone's standing up Kubernetes, trying to get it right, making mistakes along the way. We make software that makes it easier to know how to get things right, how to configure things right. So we are looking across hundreds of thousands of workloads, across hundreds of organizations, and taking that data and building this benchmark report. And we're going to cover topics today such as reliability, security, as well as efficiency. So we cover all of that. At the end, we're going to have a brief demo of the software. So if you stick around and you're curious about how we've gotten this, we can show you what that software looks like, because all of this data is built off of things that we've collected as a result of that, anonymously, obviously, from our customers. Let's go ahead, and before we dive in, we've got a quick poll, and I think I can click the button. Oh, there we go. Where are you in your Kubernetes journey? So are you just learning about containers in Kubernetes? Are you planning on using them in the next 6 to 12 months? Are you using only in testing, development environment, or are you using it in production? And we'll leave this up for a minute. Gives us some useful data about where you are in your process and helps us speak to the audience better, as well as we do collect this data over time too, because it's been interesting watching how, a couple of years ago when we were asking this question, people were less far along. So it helps us track some of the market as well. And click a button, any button. We'll give it about 5 more seconds. 4, 3, 2, 1. And I can't close it out, Julio, so if you want to close that out. All right, and let me see if I can find the results here. Okay, so learning about containers and Kubernetes, 47% of you said you're still in that phase. 6% said planning to use in 6 to 12 months. 18% said using it only in testing in a development environment. And 30% said you're using it in production. So we're at pretty far ends of the scale for the vast majority of you, either already up and running it in production or just still learning about it, which tends to match some of the things that we've seen so far. But let's dive in. So how do you compare? We're excited to talk you through this. And Robert, before we get started, why don't you talk about these graphs and how to read them so that people can understand as we go through?
Yeah, thanks, Kendall. So we basically looked at every organization and figured out, for a given check, how many of their workloads are affected by this particular problem. So for instance, in this missing liveness probes example, you can see about 35% of organizations only have 0 to 10% of their workloads affected. So 35% of organizations are doing pretty well. On the other end of the spectrum, about 2% of organizations have 90 to 100% of their workloads affected by this issue. So hopefully that gives you a sense for kind of how to read these graphs as we go through them.
Yeah, great. And let's talk about this. I mean, start with, first of all, why liveness and readiness probes matter. Like maybe even what are liveness and readiness probes if people are still learning about Kubernetes and containers. That's a helpful place to start. And then let's talk about what it means, why it matters.
Yeah, so liveness probes are really a great way to understand, to help Kubernetes understand how healthy your application is, whether it's ready to serve traffic, et cetera. They're really critical for Kubernetes being able to tell if an application is misbehaving and if it needs to, say, reschedule one of the pods that it's on, as well as helping it to release new deployments and scale up and down. For instance, if your application is scaling up, there might be a lag between when the container starts versus when your application is ready to actually serve traffic. It might need to connect to a database or pull in some other metadata, configuration, et cetera. And in that gap period, you want to make sure you're not actually serving traffic. And so using liveness and readiness probes really lets Kubernetes know, at what point should you start diverting traffic over to this new pod. So super important to really get the most out of Kubernetes and not have any kind of downtime or blips in coverage as you scale up or release a new version of your app.
So, I mean, part of the reason why we're measuring this is a really, I don't even want to say simple, I want to say obvious thing to check for, right? Like we want to know, are you doing what we think is a very, very basic thing? And so we're seeing 65% of organizations are not setting liveness and readiness probes on all of their workloads, which is interesting.
One thing to mention about this too is like when it comes to liveness and readiness probes, right? Like this is something that those application owners, they can set themselves. So if companies are embracing sort of like a shift left or service ownership mindset, those are typically the types of things that a development team might be responsible for turning on as part of their deployment. So I think it's also not only is it sort of fairly straightforward, but it's also something that may be owned by the end development team as well.
Yeah, that's a great point. It's really something that needs a lot of application context. The application owners probably know at what point their application is ready to serve traffic, how to tell if their application is healthy, connected to the database, et cetera. So it probably requires some code on the application end to implement, say, like a health endpoint, as well as the Kubernetes configuration to point Kubernetes to that endpoint and say, here's where you need to pull to see if the application's healthy.
Great. Yep. So we've covered both liveness and readiness probes there. Anything additional to say there?
I think these are one of the more kind of core features around kind of workload reliability, but there's also several other considerations that I think you'll see us cover later in the presentation as well.
Great. Yep. CPU limits missing, or CPU limits and requests missing. Let's start with, Robert, why does that matter?
Yeah, so CPU limits and requests really tell Kubernetes how much CPU it should expect your application to use and how much it should reserve for your application. Requests are probably the most important, and you can see that that's borne out by the graphs here. About 50% of organizations have set requests on most of their workloads, the vast majority of their workloads. Requests really reserve a specific amount of CPU for your application to use. If you say, I need 1.5 CPUs for this application per pod every time, Kubernetes is going to make sure for every pod it has that chunk of CPU ready for it to use that no other application can use. Mm-hmm. So making sure that you're setting, if you don't set that, if you don't set requests at all, your application is basically vulnerable to having all of its CPU grabbed by other applications, and it might end up experiencing performance problems because it doesn't have enough CPU for it to utilize.
Great.
Yeah.
Yep.
And one thing to add to this, right? I think, like Robert mentioned, right, requests and limits are important settings for a workload so that you know how much compute to give it. I think the most important is to make sure that you at least have those requests in place. So, Kubernetes has that minimum requirement for how much CPU to allocate when it first starts up. But I think we do see from time to time organizations, they may only be setting the requests and not the limits. And sometimes there might be reasons for that. And I think that's why you see that there's a slightly higher percentage of organization that are missing the limits than the requests. So that data kind of validates that in some scenarios, there might be organizations that do set the requests, but not the limits. And again, that's sort of a situation by situation basis, I think.
And the reason you want to set those limits is, it's one thing to reserve what your workload needs. It's another thing for it to run completely rampant and eat up that impacts other workloads. That can also potentially drive up cost
exactly.
in different situations. So.
Exactly. And I think part of the reason why you're going to see some more analysis that we've done around CPU and memory requests and limits later, I think for this particular scenario where it's just completely missing, the values are not set, it is more of a reliability challenge because, Kubernetes may not allocate enough memory and there you might have an application that crashes at that point, right? But to your point, Kendall, there's also cost implications later, right? And I think you're going to kind of see where cluster efficiency and workload efficiency become important when it comes to configuration.
Yeah, I just want to touch on real quick. Some of you may have seen that at AWS reInvent, Amazon just announced this new cluster autoscaler tool. Remind me the name of it? I'm blanking
Carpenter?
on it right now. Carpenter, that's right. And Carpenter has some fancy features for spinning up certain kinds of node types based on your workload, doing some additional logic above and beyond. But even more important in that world where it might spin up a different kind of node that might cost you and your organization a fortune, you really, really need to get workload requests and limits set correctly. So we also we're not covering that in today's webinar. We also have software. It's an open source tool called Goldilocks that helps you set these correctly. I think part of the reason people don't set resource requests and limits is they don't know what to set it to. And check out Goldilocks. It's an open source project by Fairwinds. It tells you how to get that right so that you can set resource requests and limits. So you're not ignoring it out of inability to know how to go about it.
Good point.
Yeah. We'll touch a little bit more on some of the cost stuff later on, but that's important for this. So reliability, missing memory limits and requests. I imagine this is somewhat similar, but talk about this.
Yeah, I can jump in here and talk about this one. I think you're absolutely right. It is very similar as the CPU side, right? I think consistently you're seeing that 50% of organizations are missing those requests, right? And that's actually very similar to the previous slide too. So that if an organization is missing their memory requests, chances are they're missing their CPU requests and vice versa. So this usually becomes a problem that our software alerts on. When it's more of a systemic issue where, lots of workloads might be forgetting these values. But I think, even more importantly, like having memory requests set is still a very important way to ensure that your application doesn't run out of memory and, stays running when it needs to. Robert, I don't know if you have anything else to add to that, though.
The only thing I would add is just, the difference between memory and CPU requests is that, you can really start running into issues if you set your memory limits and requests too low. You're more likely CPU will just get throttled, whereas memory will actually boot your application if you exceed those requests. I think that's something really that is important to highlight. It's if you run out of memory, your application will crash likely, and you'll end up causing a pod to get rescheduled.
Yeah, and it may be a small scale outage, but it feels like an outage to your customer. Oh man, I had something profound to add about that, but no, I said and breathed in and lost it. That's how good a shape I'm in. Let's keep going. So those are the reliability pieces that we're touching on today. Again, Fairwinds Insights, which we're going to get to at the end of this, covers a lot more things than just these few bits. We're just showing you today some high-level highlights of some of the data that we've collected from some of the more obvious things. So there's a lot of things that make Kubernetes and workloads in Kubernetes more reliable, and we'll show you some of that later on today. But these are the things that we're talking about for reliability in our benchmarking report. Oh, what I was going to say is there is a Q&A on the side, just to reiterate. Julio mentioned that at the beginning, but just to remind y'all, there is a Q&A button there. I will try to answer questions as we go if they're relevant, and or at the end we'll definitely have some time to get to some. So please don't hesitate to use that if we're bringing up questions as we go. Let's talk about efficiency for a minute. So we've talked about not setting resource request or limits. Let's talk about memory limits being too high or too low and what that means. Robert, you want to dive back into that one?
Sure. Yeah. So when you set those requests and limits, oftentimes developers will just kind of make a stab in the dark. They'll guess, okay, maybe my application needs 2 CPUs for each pod and 2 gigabytes of memory. What we tend to see is that developers will overestimate because the application is not going to crash under those conditions. No one's going to come chasing them down. And typically what you end up finding is that those memory requests and limits just get set too high. So you can see about 50% of organizations have them too high for at least 10% of their workloads. Only about 30% have them too low for more than 10% of their workloads. So it's definitely much more common to set these too high.
Yeah. I was just gonna say, I think that's a really common, scenario, right? Like if we went back to the point I made earlier around service ownership and developers, may have the control over setting some of these values. A lot of times developers, they're just trying to get their application out there to run, right? And so they don't really know how much memory or CPU to allocate, right? It's generally more of an operational question. And so, it's very common for a workload, even a small microservice, to be given lots of memory and CPU, and in reality, in the runtime, it doesn't actually need that much. So being able to have instrumentation and observability into how your workloads are behaving, so that you can monitor the actual CPU and memory usage over time, that's been some of the tooling recommendations that we've given our clients as they go out and try to solve this problem.
Great. Y'all ready to go? Keep moving?
Let's keep moving.
Okay. 50% of organizations have at least half of their workloads affected by a suboptimal pull policy. Talk about what a pull policy is, why it matters, and what a suboptimal pull policy is.
Yeah, so we recommend to all of our customers that they set pull policy to always on their workloads. That can be a little bit inefficient. Sometimes Kubernetes will try to cache images on their nodes in order to avoid pulling again. But what that can do is lead to inconsistencies where maybe one node has one version of an image cached, another node has a different version, and suddenly you're serving 2 different versions of your application within the same cluster. And that can lead to a lot of issues. There are also some security implications, et cetera. So we generally have a blanket recommendation to set the pull policy to always.
You don't want to have issued a patch for a known CVE and have images continue to run, or pulled cached images to be attack vectors in the in-between. It's a little bit of a stretch depending on a whole bunch of different things, but that is a theoretical possibility, right?
And Robert, this is a pretty quick fix usually too, right? It's kind of a one-line change.
This is as easy as it gets. It's a one-line change that will not break your application no matter what.
Awesome.
Yeah. And would you file this more in security? Would you file this? I mean, it could be in anything, because there could be a reliability problem that you need to patch in the application, and it's not going out patched. So it affects all three of these categories.
It really does,
Okay.
yeah.
29% have made a point of enforcing a pull policy for the majority of their workloads. So I talk a little bit about that vector. 50% of organizations have at least half of their workloads affected by a suboptimal pull policy. That's probably lacking a pull policy or the wrong pull policy. And we're saying 30% of the organizations have made a point of setting a pull policy for the majority of their workloads. So how do those two numbers jive? And is it that they're setting the wrong pull policy? That's part of it.
Yeah, so really what we see when we look at the numbers is that there's kind of a binary distribution. There are organizations who, like us, think it's extremely important to set the pull policy to always in all cases. And you can see that when you look in their clusters that the vast majority of workloads, if not 100% of their workloads, have pull policy set to always. But then there's organizations who don't set it, or set it to other things, or don't really have a policy around what that should be set to. And you see a lot of their workloads not having the pull policy set to always. So it's really kind of there's kind of two categories of organizations: the ones that really care about this, and the ones that don't seem to know about it or understand it.
Great. Let's keep going. Let's dive into the security side. So security is important, and part of the reason, a big part of the reason probably many of you come to a benchmark conversation is you can never be completely secure. There are always trade-offs, and so you're wanting to wonder, you're wanting to know how secure am I compared to others. And so let's talk about some of these insecure capabilities.
Yeah. So this is one of those things that it's not really, I'd say, secure. Kubernetes configuration isn't necessarily secure by default. These insecure capabilities are specifically pointing to capabilities that are enabled by default in Kubernetes and have to be actively dropped by whoever is configuring the workload. So you see this very binary distribution here, where about 42% of organizations have actively gone in and dropped these capabilities that they don't necessarily need for the vast majority of their workloads. Whereas a lot of organizations have left these on, as many as a quarter have left these capabilities attached to the vast majority of their workloads, even though most workloads aren't going to need these capabilities.
I mean, give an example of insecure capabilities, Robert. We're talking about containers that are running as root when they don't need to be running as root, that kind of thing.
Yeah, exactly. It's a set of Linux capabilities essentially that give the container permission to do things on the host node that it often doesn't need to do. They typically are very, very kind of nitty gritty features relating to how user space is managed, how process IDs are managed, things like that. And typically it's safe. Your application is going to continue working if you just drop all of these capabilities.
Yeah, and one of the cool things about the Kubernetes community is there's lots of open source, right? So there's actually been, I think, one of the first categories of configuration auditing that has come out has been in the security space, right? Our open source offering, Fairwinds Polaris, is actually one of the leading tools in this space to help detect these types of insecure capabilities with your Kubernetes configuration. But I think one of the things that we've noticed is, aside from just the insecure capabilities that might accidentally be introduced, there's also those reliability and efficiency challenges with configuration as well. And so when you step back and look at it broadly, you need to, because Kubernetes can be configured insecurely from the start, you also need to make sure that you're configuring things efficiently and reliably from the start as well. You don't want to lose out on some of those intentional configurations as well.
Great. Okay, let's keep going. Privilege escalation is allowed. 42% are managing to lock down the vast majority of their workloads. Most organizations, 54%, have left more than half of their workloads open to privilege escalation. And this is in the same vein. Go ahead, Joe.
Yeah, very, very similar concept here, right? I think with privilege escalation and Robert, correct me if I'm wrong, I think this is sort of on by default as well, right? And you have to make some intentional decisions to disable that. There's fortunately a number of ways you can construct your configuration to either enable or disable some of these settings out of the gate. but it is often, as you can see from the data, still a fairly large number of organizations, 54% have left their workloads open to some amount of privilege escalation here. And I think that's the key problem that, still needs to be sort of resolved in the Kubernetes space.
It's too easy to do things wrong. And part of that is they have to build Kubernetes with to be by default over permissioned because it's new and people are going to come in and they're going to try things and nothing's going to work if they've locked everything down as much as they can. So they leave it broadly open so that you can explore and make sure things work. But once you become more mature as a user of Kubernetes, as an organization running Kubernetes, you need to know what to go in and lock down. And again, this is specifically the space we play in. That's why we have this data. Let's keep going. Run as root allowed. Here's the example I was giving a minute ago. So this is a subset of the insecure permissions that we were looking at before. Is that right, Robert?
Right. So the insecure permissions we were looking at before is actually a list of Linux capabilities, essentially. So this is a separate field of Kubernetes configuration. Related though, that would allow the container to essentially run as root on the host node. So this is important because if somebody were to manage to escape that container, they would have excessive permissions on the host node and could potentially infiltrate other applications, other containers. It's a really easy setting generally. Most workloads have no need to run as root. And then you really just have to set the run as root allowed equals false on the Kubernetes configuration. But again, this is not something that's enabled by default. So it's something that teams actively have to do. You can see, about 30% of organizations are actively setting this on the majority of their workloads, but there are a lot of organizations who have not bothered to set it for many of them.
Great.
Yep.
And let's keep going. Image vulnerability.
Yeah, this is another a really popular types of finding, if you will, in terms of security issues that can be found in the cluster, right? So if you are a lot of applications being deployed to Kubernetes, a lot of them are obviously first-party applications that companies build and maintain themselves, but there's also a fair number of kind of third-party open source add-ons that might be added to a cluster. And so when you go to analyze those container images, you'll more likely than not find that there might be known vulnerabilities or CVEs associated with those versions of those containers. And so for the container images that you own and maintain, that's obviously within your control to be able to upgrade those packages and fix those vulnerabilities. But for the third-party containers, right, you have to sometimes work with the upstream maintainer to make sure that they're patching those. And so image vulnerabilities are obviously important to monitor and understand the risk, but it's also in conjunction with some of the security configuration that we talked about, like running as root and privilege escalation. You want to make sure that you're only using the proper configuration or the proper permissions, if you will, around the security capability, so that you're not, opening up those containers to do more damage inside the cluster if they're ever breached.
Yeah, it's a great point. All these different security checks kind of play into one another. In order to really tighten things down, you want to make sure you have an eye on all of them.
Great. Well, we've got one more main finding that we're going to talk about, and then we're going to shift gears a little bit. But let's talk about outdated Helm charts and deprecated APIs and why that matters.
Yeah. So for Helm charts in particular, each of the add-ons that you're putting into your Kubernetes cluster typically are being released. Maybe there's a new release, once a month, once a quarter, or something like that. And keeping those up to date is really important for making sure that any security vulnerabilities that get announced in those applications. There was recently a fairly big one, an Nginx Ingress, for example. Making sure those get patched and put in is super important. So we like to help our customers really keep an eye on what Helm charts they have installed and what version they have installed versus what's the latest version available. And if there are security patches available, if there are new versions available, prompting them to install the new versions. It's super important to keep on top of, just to make sure that you're not vulnerable and you're getting all the latest and greatest features and bug fixes.
Yeah, just to kind of follow up on Robert's earlier point, there are lots of add-ons that are used in Kubernetes, things that help with certificates or DNS, et cetera. And you might install those third-party add-ons via Helm method, right? So as those maintainers update their container images or add features that improve security or improve reliability, it's important that you want to upgrade to the next stable version. So keeping track of your version of your add-ons is really important just for overall cluster maintenance.
Great. So let's shift gears here a little bit. I'm going to move my windows around on my screen. So this data is collected from Fairwinds Insights. I've alluded to this. I've mentioned it a few times. We make software at Fairwinds for governance and security from CI/CD through production. As I've mentioned, everybody's using Kubernetes. Not everybody's confident they're doing it right, or increasingly everyone's using Kubernetes. I shouldn't say everyone's using it yet. It's the adoption's happening fast, but there's always folks that are going to be slower to it. But Fairwinds Insights is software that gives you confidence that the way you have configured things is correct and keeps your engineers, particularly in a service ownership environment, from deploying things that they shouldn't be into the cluster. And we're going to show some of this to you. So Insights is solving cloud native challenges, including security, cost optimization, and it also includes policy and guardrails. And let me just pull this up, and I'm going to go ahead and just dive in and show you what Fairwinds Insights looks like. So this will be a brief demo, and then we're going to get to questions. I do want to say again, please do pop over to that Q&A tab and punch in questions if you have them, so we can get to the questions as soon as we're done with this. But so say you've installed Fairwinds Insights on 2 clusters in your organization, and you log in, you'll get a dashboard that looks like this, where we're giving you an overall health score, telling you your organization gets a C+. And we have 2 clusters here, as well as we're tracking how that health score is changing over time. And we're also showing you what the top issues are that we found across your organization. So image has vulnerabilities. Image pull policy should be set to always. This is one of those ones that we talked about, right? And if I click into one of these clusters, it takes me to a cluster dashboard where it's going to show me where action items have been introduced into the cluster. It's going to track that health score over time. It's going to give me a health score that's specific to this particular cluster. And we're breaking down a whole bunch of action items that we're finding into passing, critical, high, medium, low priority. And I'll show you what that looks like in a minute. We do also track some cost changes over time so that you can take a look at that and have a bird's eye view of like, oh, that spike is maybe expensive, or that down spike is maybe bad. What happened there? There's all kinds of things that can, you just get the bird's eye view here where you need. So where are we pulling information from? We're collecting a whole bunch of reports from open source that we've created, as well as third-party open source. So Polaris is our open source tool for common Kubernetes misconfigurations. This was some of the genesis of how we got to Insights, is managing lots of infrastructure over time, because Fairwinds has a history as a services organization, building and maintaining clusters for organizations. We've seen what are the misconfigurations that everyone struggles with. Well, everyone fails to do X, Y, or Z. Polaris is an open source tool that checks for that. We also have Nova checking for those out-of-date Helm charts, Pluto checking for deprecated APIs, Goldilocks gets your resource requests and limits just right. But we're also pulling in information from Trivy, KubeBench, KubeHunter, KubeSec. These are third-party open source tools that we're also aggregating. Any of these can be you can go and set up any of these tools on a individual Kubernetes cluster. Operationalizing them at scale across lots of clusters is very difficult without software like Fairwinds Insights. We also have support for OPA. So if you're writing custom policy, that's something that you can do here. And I'm going to make my window a little bit bigger. Let's see how that looks. There we go. So we aggregate all that data and drop it into this big action items list. And you can sort by criticality. So you can say, well, what are the high, medium, or low problems? Usually people are trying to knock off the critical issues. and you can click into any one of these issues, and it's going to tell you both what the problem is and, importantly, how to go about fixing it. So you don't have to have a whole bunch of Kubernetes experts in your organization in order to improve upon what's been built. You can assign that to somebody in Insights itself. You can say it's working as intended or you're not going to fix it. And you can also kick that out to a ticketing system if you have one, and take care of it there. Now, if we're waiting until things are broken in production before we're checking for them or stopping them from getting, you can't stop it from getting there if it's already in production, it's too late, right? So waiting for these action items to show up on this dashboard is already in some ways too late. So we have integration in the CI pipeline and your CD pipeline. So here we've got an engineer running a container as root, adding in secure permissions to the container. And this is in GitHub. It can work with any Git system, but this is in GitHub Actions where we're plugged in, and you can see Circle CI is passing the tests. Fairwinds Insights is failing it down here. And so then that engineer can click on this button. It's going to load them into the UI, say, hey, here's what's wrong. Here's how to go about fixing it. And then you go knock off those few things, issue that pull request again, and it's going to pass. Does that make sense? And I've got a few other things I'm going to show you yet. So we do have some workload logic where you can see all the different applications or services running in your cluster, what percentage of the relative total cost is coming from that workload, track that daily. This isn't changing very much because the cluster is not super active. But we're going to give you suggestions for how to configure your workloads just right. So you can set this to be, you want to say something, Joe?
Well, I was just going to say, yeah, I think there was an earlier example where we talked about memory or CPU being too high or too low. This is a capability here that's going to measure the actual CPU and in memory that you're currently using and give very specific recommendations on what we believe that requester limit should be set to. So it helps developers, avoid the guesswork and set the right value so they can just move on to shipping their applications faster.
Right. Yeah, I'll pull up that graph here in just a second. So you can select a quality of service. You can say this is a critical service that needs to always be up, and we're going to suggest that you provision that slightly higher. You can say this is one that can afford to be, burstable or limited, and we're going to give different recommendations based on that. And you can see we are not a cost-saving software in the way that some companies go about just saving you money. Now, we often do save our customers lots of money, but our approach is correct configuration, and that's how this software sits. So there's times where we're telling you to actually spend more money because this is a critical workload, and you can see this is a $8 per month change. That's not a very big deal when you're running one pod. If you're running lots and lots of pods, if you're using different kinds of instance types, that number can go up very quickly. But as Joe said, so we can click into this. We actually show you memory usage over time, show you CPU usage over time, and then we can calculate this is what you're actually using. So this is our recommendation, and then this is what the difference is. And we have some cost analysis on that. So again, we're approaching this from we want to help configure things correctly. And the reason so many companies often are not setting resource requests and limits is because they don't know how to. And you can guess at something, set it, run it in the cluster, and use Fairwinds Insights to come back and find out how you need to tweak it to be just right. There's a lot more here. This is a dashboard showing you what's deprecated versus what's out of date in terms of the add-ons running in your cluster. We have ways to do automation, so you can say create a Jira ticket for every application running in this namespace with these kinds of problems, that kind of thing. And you can also write custom policy with OPA, as we mentioned. So there's a lot more in Fairwinds Insights. If this at all piques your interest, if you're running Kubernetes and you want to run Kubernetes better, that's what Fairwinds Insights exists to solve. Reach out to us. We're happy to put you in touch with folks. We have a free demo. If all you do is sign up and attempt, install this on a cluster and see how you do, and you decide you never need it because you are crushing things today, great. We are happy with that outcome, but we're happy to set you up and run a free trial for you, and we think you'll be impressed. So that's Fairwinds Insights. Let's go back and pull up a poll, and then we'll dive into questions. So what is your greatest opportunity to improve your Kubernetes environment? Do you need help getting help with the basics, general best practice assessment. Are you having trouble improving the security posture of your clusters? Do you really need to save money because it's costing you all the money? Or are you looking at improving the reliability of your applications and services running in Kubernetes? So we'll leave this up for a minute. Click a button. Tell us what you think. Sing some Jeopardy music. I noticed that whenever we do these and I start singing Jeopardy, Joe and Robert never unmute and dive in with harmony, and maybe we can work on that next time. Okay, we'll give it 7 more seconds. 5, 4, 3. Click a button now while you still can. 2, 1, and we'll close that out. I'll go over here to our polls and pull up the details. Okay, so pretty even split across all but the first one. So 8% saying getting help with the basics, and almost even across all the rest. So
security, saving money, improving reliability. Yeah, I mean, I think that's the kind of the thing. One of the key points we're trying to make today too is, configuration can drive all those different outcomes, right? And so, a lot of times folks will start looking at the security posture configuration, which is key, but there's also, how do I make sure it's efficient? How do I make sure it's reliable? So I think it seems like that this audience has a very similar view in terms of needing help on those same 3 areas.
Yep. And so if you want to take a look at our benchmark report, here's a couple of links. You can go check out these things. You can also click one of these links or type in one of these links, I guess, because you can't click on it on the window here. But you can, here, I'll dump both of these in. Somebody dump those in the chat for me, just so that somebody has some place easy to click on. And let's look at some questions. So we have a few Q&A. Please do, again, drop in the Q&A thing here if you have questions. What is the most common security mistake you're seeing people make? Do we know that off the top of our head? Robert, Joe?
I'd say the most common, I don't know if it's necessarily the most common, but I guess combining both how common and how severe, I would say, is having known vulnerabilities running inside of container images. Is a very, very common thing. It's a hard thing to keep on top of because new vulnerabilities are getting announced every day. And you really need to make sure that you're not only scanning your images as you build them or as you push them to your registry, but you need to make sure you're actively scanning images that are running in your cluster. Because if a new vulnerability gets announced, you've already shipped that image to your registry and it's running in your cluster, you need to make sure you have eyes on that you're applying the new scan for the new vulnerability to those images that are already running. And so it's rare to find a cluster that has no vulnerable images inside of it.
Right.
Yep.
Yeah, and I think a close second there is probably a variety of insecure configurations, just because, as we were sharing, a lot of those configurations require intentional decisions to make it secure, right? And so the defaults aren't necessarily there to allow for secure configuration out of the gate. And so I think that's another area where a lot of workloads may be affected.
Great. Next question, where should we look first if we're trying to optimize cost in our clusters? Joe, were you going to say something?
Yeah, I think there's a number, when it comes to optimizing cost in Kubernetes, frankly, there's a number of different approaches you can take, right? I think the approach that we've seen a lot of customers struggle with is really what we call app right sizing. So being able to, if you go back to the earlier example of workloads missing requests and limits or having too much memory or CPU allocated, those are usually areas where it's a guess and folks are guessing on what the value should be. And lots of times it's over provisioning those, which means that if you're over provisioning those workloads, you're actually consuming more compute resources than you need. So helping with app right sizing and focusing on your most expensive workloads or your most provisioned workloads can help you, better save money within Kubernetes. And so that is an area that, in the demo that you share with Insights, that's something that we can do with Fairwinds Insights. And we also created a tool for the community called Goldilocks, which can give you some recommendations as well.
Great. Thanks, Joe. Last question we have right now. Folks have other questions, feel free to drop them in. But how many clusters do you need to have in order to benefit from software like Insights? Good tee-up question. Honestly, well, Robert, were you going to say?
So I was going to say, I think, while Insights does tend to shine in multi-cluster environments, making sure that you have those best practices in place, even as maybe a less mature organization just getting started with Kubernetes, getting those best practices in place early is definitely very helpful. So while I would say you'll get the most benefit out of Insights in a multi-cluster environment, it's good to start small too with a single cluster and make sure that you're setting yourself up for success rather than creating technical debt that you're just going to need to address down the line.
Yeah, I think that I've seen even very large organizations run things like one cluster and a billion different namespaces and applications running in it. I haven't actually seen a billion, to clarify. I am adding emphasis. But having those workloads correctly configured when they're deployed into Kubernetes, whether it's one cluster, whether it's a whole bunch of clusters, that proper governance goes a long way. So it's not necessarily how many clusters you have. So, any other questions? Otherwise, we'll wrap up a little bit early, and I can turn things back over to you, Julio. Otherwise, thanks for being with us, folks. If you want to know more, we shared both those links in the chat. Those are clickable. And Julio, take it away.
Excellent. Just as a reminder that today's webinar has been recorded, so if you missed any or all of the webinar, you will be able to watch it again. We will be sending a link with an email with a link to access the webinar on demand, and you can also find it on devops.com. Just look in the on-demand section in the webinars page, and you should find it there. Our 4 winners of the Amazon gift card today are Tan M. Congratulations, Tan. Ron B. Molly P. and John R. So congratulations to all our winners. We'll be reaching out to you via email with instructions for claiming your Amazon gift card. So please check your inbox. And if you don't see it there, check your spam folder. Kendall, Joe, and Robert, thank you very much for taking the time to put this presentation together and for giving us an hour of your day. We all appreciate it.
Thank you.
I'd also like to thank the audience for their time and engagement. This is Julio Godinez signing off until next time. Be well, everyone.